Hi everyone, we are in our fourth video where we're looking at the normal distribution MS5, which is within the topic of statistical analysis. So in this video, we're going to be talking about Z-score. So a Z-score is a statistical measure of how many standard deviations a raw score is above or below the mean. So if our Z-score is positive, let me write this up quickly. If our Z-score is positive, it is above the mean. And if it's negative, it is below the mean. And so if you remember when we were drawing our bell curves, we'd have the mean and we would do one standard deviation above and one standard deviation below. So that's where we get the positive and the negative from. If it's a positive number, it is above the mean going that way. And if it's a negative number, it's below the mean going the other way. So a Z-score can be calculated using this formula. So it's an important formula to know. It is on your reference sheet, but you may have seen it look like, Z equals X minus the mean of X over S. So these are interchangeable ways to write it. Personally, I like this one better. It makes more sense to me, where Z equals the Z-score, X equals the score that you've been given. This here, or this symbol here, that's just the mean of the set of scores, and S is simply the standard deviation. So remembering this formula, you can answer questions on how to find the Z-score, which is just telling us how many standard deviations above or below the mean a certain mark is. So if we have a look at the next question, if we can go there, scroll to the next question. Here we go. Here we are. So if the mean is 83, we need to remember that, and the S standard deviation is 3.2, find the Z-score of a mark of 74. So first thing to do is to write out your formula. So our formula is Z-score, or Z equals X with the mean of X over our standard deviation. Now I'm going to sub what we know. So we're trying to find Z, we're trying to find the Z-score. We know what the mean is. Our mean equals 83. Our standard deviation equals 3.2. And the mark, or the score we've been given, is 74. So now I'm going to sub these values into my formula, where Z equals X minus 83 over 3.2. And if you pop that into your calculator, you will get a Z-score of negative 2.8125. So this is indicating that if we have a mean here of 83, the mark of 74 is going to be almost 3 standard deviations below the mean. It's going to be around here, 2.8 standard deviations below the mean. Now let's have a look at another question for Z-scores. Just wait for my computer to load. Oh, I think we went too far. There we go. So Ruby gained a mark of 70 in her test. So that's our mark of 70. What is her Z-score? So we're trying to find the Z-score. If the mean was 78 and the standard deviation was 6. Answer correct to 1 decimal place. So firstly, if you remember what we did in the last question, our first step was to write out the formula, which looked a little something like that. Now you can go and you can sub what you know. So we know X, which is our score, is going to be our mark of 70. We know the mean is going to equal 78. And we know the standard deviation is going to equal 6, according to the question. Now we can go and sub that into our formula. So 70 minus 78 over 6 equals our z-score, which equals negative 1.3. So you just pop this simply into your calculator and it'll pop out with negative 1.3, which indicates that a mark of 70 is 1.3 standard deviations below the mean. And we can check that by knowing 70 is below 78. So if our mean is 78, we know that 70 is going to be down here somewhere, and it's going to be 1.3 standard deviations below. And let's do our final question. Here we go. The heights of a group of young women have a mean of 160 and a standard deviation of 8. Determine the z-scores of a woman who is. Okay, let's answer question A. Actually, let's do it down here so we have more room. Question A. I'm going to write our formula up here so we don't forget it. And I'm going to go and sub what I know. I know X is going to equal my score, which is 172. My mean of X is going to be 160, and my standard deviation is going to be 8. So now I can sub that in for Z equals 172 minus 160 over 8. And that's going to give me a score of 1.5 standard deviations above the mean. Now let's do question B. We're going to do the same process. X equals 150, the mean of X equals 160, and standard deviation equals 8. So sub those in. Z equals 156 minus 160 over S, which is 8, which equals 1.25, negative 1.25. So that's 1.25 standard deviations below the mean. And I'm just going to erase question B quickly so I can do question C. Here we go. Question C. We have X equals 160, mean of X equals 160, and standard deviation equals 8. Sub those in for Z equals 160 minus 160 over 8, and pop that in your calculator and you will get a z-score of 0, which means that we're at the mean. We don't have a z-score, we're just 0. And so z-scores, as you can see, are really helpful. This formula for a z-score is really helpful to calculate what standard deviation you are when it's not exactly 1 or exactly 2. So if you remember our bell curve, let me just do it in black. Ooh. Our bell curve, we have the mean here, and then we would have 1 standard deviation below the mean, above the mean, 2 standard deviations above the mean, 3 standard deviations above the mean, 1 below, 2 below, and 3 below. But what if you have a mark that is here, 1.5? How do you know? That's when you use the formula. So this formula is really helpful to tell you what where your mark lies on your bell curve. Because if it's not a simple 1, 2, or 3, if it's a 1.75, how are you supposed to know that unless you use the formula? So that's why the formula is really helpful and really important to calculate z-scores that are not a simple 1, 2, or 3 standard deviations above or below the mean.